Hi students, good morning. So welcome to the session 3 of work energy power chapter. So in Canada we will continue with our discussion about the conservative force. Already session 2 we have looked at this classification, right? What is it that we were doing in the last of the second session? We were looking at the classification of the forces into ஒரு சைடில் கன்சர்வேட்டிவ் ஃபோர்ஸஸ் இன்னொரு சைடில் நான் கன்சர்வேட்டிவ் ஃபோர்ஸஸ். ஸோ கன்சர்வேட்டிவ் ஃபோர்ஸோட பேசிக் ஐடியா என்ன? இஃப் யூ லுக் எட் ஒர்க் டன் பை த கன்சர்வேட்டிவ் ஃபோர்ஸ் இன் க்ளோஸ் லூப், ஒரு க்ளோஸ் லூப் எடுத்தால் அந்த க்ளோஸ் லூப்புக்குள்ள வாட் இஸ் தி ஒர்க் டன்? இப்போ ஒரு பாயிண்ட்லேருந்து ஸ்டார்ட் பண்ணி அப்படியே திருப்பி வில் கம் பேக் டு த சேம் பாயிண்ட்னு வச்சுக்கோங்க. தட் இஸ் வாட் யூ கால் அஸ் அ க்ளோஸ் லூப் ஆர் அ க்ளோஸ்ட் பாத். ஓகே, ஸோ அந்த மாதிரி ஒரு மூமெண்ட் இருந்தால் தென் யூ நோ தி ஒர்க் டன் பை த கன்சர்வேட்டிவ் ஃபோர்ஸஸ் வில் பி ஜீரோ. அதுக்கான எக்ஸாம்பிள்ஸ் என்ன? எலக்ட்ரோஸ்டாட்டிக் ஃபோர்ஸ், கிராவிடேஷனல் ஃபோர்ஸ், நிறைய எலாஸ்டிக் ஃபோர்ஸஸ். அதில் ஒரு ஸ்பெஷல் கேஸ் இஸ் வாட் வி கன்சிடர் ஸ்ப்ரிங் ஃபோர்ஸ். ஓகே, அந்த மாதிரி மேக்னெட்டிக் ஃபோர்ஸஸ். ஓகே, இதெல்லாம் என்னது? கன்சர்வேட்டிவ் ஃபோர்ஸஸ். இப்போ என்ன வி லுக் எட் எப்படி ஹவு த கிராவிடேஷனல் ஃபோர்ஸ் இஸ் பிகமிங் கன்சர்வேட்டிவ் ஃபோர்ஸ், ஹவு த ஸ்ப்ரிங் ஃபோர்ஸ் பிகம்ஸ் எ கன்சர்வேட்டிவ் ஃபோர்ஸ். ஓகேவா? ஸோ வில் சி ஹவு தே சாட்டிஸ்ஃபை த கண்டிஷன். இதுக்கு கண்டிஷன் என்னது? For a conservative force, work done in a closed path should be zero. Okay, paranga. So we will try to prove how the gravity can be called as a conservative force. Adukku enna theriyuma? We will take the example that we already discussed. Idu munadi remember, you know, work done by the gravitational force. Work done by the gravitational context la nama discuss pannirkom. Remember, if take a point from 1 to 2, take a mass from 1 to 2. Okay, so point 1 and point 2 கிட்ட நம்ம எடுத்துட்டு போனா it is what giving a vertical displacement h. Okay va, giving a vertical displacement h. So அந்த ஒரு particular pathல what is the work done by the gravitational force already நம்ம calculate பண்ணிருக்கோம். So gravity will be acting downwards, we are giving a vertical displacement h upwards. So both are having an angle of 180 தானா? So work will be what? minus mgh. இது ஆல்ரெடி நம்ம பார்த்துருக்கோம். ஓகே, இப்போ என்ன தெரியுமா? we will try to make the motion a closed loop. எப்படின்னு பார்த்தா லைக் யூ நோ we will அப்படியே அந்த 2லேருந்து திருப்பி நம்ம 1 கிட்ட கொண்டு வரலாம். ஸோ ஃபர்ஸ்ட் நம்ம என்ன பண்ணியிருக்கோம்? we are taking it from point 1 to point 2. ஓகே, இது அப்போடு மேலே போகிற மாதிரி. திருப்பி நம்ம கீழே எடுத்துகிட்டு வந்தால் வாட் இஸ் இட்? க்ளோஸ் லூப் தானா? ஏன்னா we are coming back to the same original starting point. ஓகே, ஸோ இப்போ திருப்பி நம்ம கீழே வரும்போது we are having the same displacement h, பட் இங்கே எப்படி இருக்கு? that displacement is what? downwards தானா? ஸோ நம்ம கீழே எடுத்து வரும்போது what is the displacement? downwards. ஓகே, gravitational force எப்படி ஆக்ட் ஆகும்? downwards தானா? ஸோ what is the angle between them here? பாருங்க, both are in the same direction. ஸோ angle எவ்வளோ? 0. ஸோ அதனால what is the work done when we bring it from 2 to 1? இது இந்த வேல்யூ நம்ம ஆல்ரெடி கால்குலேட் பண்ணியிருக்கோம். ஸோ remember I told you that time that note these values ன்னு சொல்லிட்டு. ஸோ இங்கே எப்படி பாருங்க, the force is mg and displacement is h, both are in the same direction. அதனால work will be what? mgh. when we say work done in the closed loop, இப்போ நம்ம எடுத்தது என்ன? closed loop தானா? the one that you took is a closed loop or a closed path. ஏன்னா point 1லேருந்து ஸ்டார்ட் பண்ணிட்டு we have gone to point 2, திருப்பி we come to point 1. இது என்னது? க்ளோஸ் லூப் மாதிரி தான். ஸோ ஒர்க் டன் இந்த க்ளோஸ் லூப் எவ்வளோ? அந்த ரெண்டு ஒர்க் டனோட வேல்யூஸ் நம்ம அப்படியே ஆட் பண்ணணும். பிகாஸ் ரிமெம்பர் ஒர்க் இஸ் அ ஸ்கேலர், வி கேன் சிம்பிளி ஆட் இட் அப். ஓகே, ஸோ பாருங்க, மைனஸ் mgh ப்ளஸ் mgh ஆட் பண்ண என்ன வருது? 0. புரியுதா? ஸோ இதனால we will say that you know work can be a conservative force. பட் இதில் என்ன தெரியுமா? there is a tricky thing here that we have to note it down. And when we look at any proof, like say for example நீங்க ஒரு sin square theta plus cos square theta is equal to 1 இது நம்ம ப்ரூவ் பண்ணணும்னா what you have to do? you have to என்ன சொல்றது? prove it for all cases. sin square theta plus cos square theta is equal to 1 ப்ரூவ் பண்ணி வச்சுக்கோங்க. நம்ம ஒரு எக்ஸாம்பிள் எடுத்துட்டு அது கரெக்ட்னு சொல்ல முடியாது. இப்போ sin ஸ்கொயர் 30 + cos ஸ்கொயர் 30 = 1. அப்படி அது சாட்டிஸ்ஃபைட் ஆரிக்கான்னு சொல்லிட்டு we cannot say that always sin ஸ்கொயர் θ + cos ஸ்கொயர் θ = 1 அப்படி சொல்ல முடியாது. ஏன்னா நம்ம ஒரு ரிலேஷன் ஆகட்டும் ஆர் தட் ஐடென்டிட்டி ஆகட்டும் அதை நம்ம ப்ரூவ் பண்ணோம்னா we cannot prove it by taking a single example. புரியுதா? ஒரு எக்ஸாம்பிள் எடுத்துட்டு நம்ம ப்ரூவ் பண்ண முடியாது. you have to prove it for all the cases. அதனால என்ன தெரியுமா, in mathematicsல you will be having these two methods. one is general case method ன்னு சொல்லுவாங்க. என்னது, whenever we are proving something right. ஒன்னு general case method. ரெண்டாவது, if you are familiar with mathematics, right, induction method, mathematical induction ன்னு சொல்லுவாங்க. Okay, so that's the reason why they will generally, இப்போ ஒரு identity or know that a relation is there, you want to prove it means how do you prove it for all the cases? ஏன்னா எல்லா கேசஸ்க்கும் நம்ம கவர் பண்ணதா that will be called as an identity or that will be taken as a correct relation. நம்ம ஒரு எக்ஸாம்பிள் எடுத்துட்டு ப்ரூவ் பண்ண முடியாது. ஓகே, சிமிலர்லி இப்போ லாகரிதம் ஒரு ரிலேஷன் எடுங்க வச்சுக்கோங்க. ஸோ நம்ம என்ன சொல்லுவோம், log of ab is equal to பாருங்க, log of ab is equal to log a plus log b. இது ஆல்ரெடி நம்ம யூஸ் பண்ணியிருக்கோம் ஈவன் இன் த கேஸ் ஆஃப் தட் என்னது தி ராக்கெட் ஈக்குவேஷன்ல நம்ம இந்த ரிலேஷன் யூஸ் பண்ணியிருக்கோம். ஓகே, ஸோ இப்போ இது ப்ரூவ் பண்ணோம்னா யூ cannot take one example and say that okay, take a is equal to 10, b is equal to 100 அப்படி எடுத்துட்டு we cannot say that relation is correct. Proving means you have to take a general proof. Okay, இல்லைன்னா you have to prove it by using that mathematical technique called as what, induction method. ஸோ இங்கே என்ன தெரியுமா, we are not proving it in the general case. அது மட்டும் நம்ம ஞாபகம் வச்சுக்கணும். we have taken ஒரு எக்ஸாம்பிள் தான். ஓகே, ஒரு எக்ஸாம்பிள் எடுத்துட்டு we are able to see how the gravitational force is becoming a conservative force. ஸோ இதில் என்ன, I put the heading as proving, பட் நம்ம என்ன ஞாபகம் வச்சுக்கணும், we are trying to analyze. இது proof கிடையாது, we are trying to analyze how the gravitational force is satisfying the relation of the conservative force. ஏன்னா நம்ம எடுத்தது என்ன, இது ஜெனரல் கேஸ் கிடையாது. ஏன்னா ஜெனரல் கேஸ்ன்னு சொன்னா என்ன தெரியுமா, யூ கேன் மூவ் த ஆப்ஜெக்ட் இன் வாட் எவர் வே யூ வாண்ட். பட் நம்ம எடுத்தது என்ன, ஒரு சிம்பிள் எக்ஸாம்பிள். என்னது, வி டேக் இட் அப், திருப்பி கீழே எடுத்துட்டு வர மாதிரி. ஓகேவா? ஸோ தட் இஸ் த ரீசன் வை வைல் வி புட் த ஹெட்டிங் ஆஸ் அ ப்ரூஃப். பட் இது என்ன தெரியுமா, வி ஆர் ட்ரைங் டு அண்டர்ஸ்டாண்ட் எப்படி how the gravitational force is also becoming like an or behaving like a conservative force. அதுதான் நம்ம இங்க அனாலிசிஸ்ல பார்த்திருக்கோம். ஓகேவா? நெக்ஸ்ட் என்னன்னா, we will see how the spring force will behave like a conservative force. இதுல ஒரே ஒரு ஸ்மால் சிச்சுவேஷன் என்ன தெரியுமா, ஸ்ப்ரிங் ஃபோர்ஸ் சொன்னா இட்ஸ் a வேரியபிள் ஃபோர்ஸ். இப்போ நம்ம இதுக்கு முன்னாடி டிஸ்கஸ் பண்ணது என்ன, கிராவிடேஷனல் ஃபோர்ஸ். கிட்டத்தட்ட இஃப் யூ ஆர் நியர் டு த சர்ஃபேஸ் ஆஃப் த அர்த், ரைட், கிராவிடேஷனல் ஃபோர்ஸோட வேல்யூ வில் பி ஆல்மோஸ்ட் கான்ஸ்டன்ட். அதனால we have taken டிஸ்பிளேஸ்மெண்ட் h மேலே ஃபர்ஸ்ட் எடுத்துட்டு போற மாதிரி, திருப்பி கீழே வர மாதிரி. ஓகே, பட் இங்க என்னன்னா, the spring force will be a variable force. It depends upon what, அந்த ஸ்ப்ரிங்கோட elongation or the compression value தானா. ஸோ இப்போ பாருங்க, we take a spring of constant k which is already elongated by a value x. இதுலயும் நம்ம ஒரு ஸ்பெஷல் கேஸ் தான், ஒரு எக்ஸாம்பிள் தான் நம்ம பார்க்குறோம். ஓகே, ஸோ த ஸ்ப்ரிங் இஸ் ஆல்ரெடி, இப்போ பாருங்க, ஸ்ப்ரிங் இஸ் அட்டாச் டு சம் ஆப்ஜெக்ட் வச்சுக்கோங்க. ஸ்ப்ரிங் ஆல்ரெடி நம்ம எலாங்கேட் பண்ணியிருக்கோம். இது என்ன, we will consider it as a 0.1. so if the spring is elongated, right, அந்த ஆப்ஜெக்ட்க்கு மேல ஸ்ப்ரிங் ஃபோர்ஸ் ஆக்ட் ஆயிடும். எப்படி, the spring force will be restoring force தானா. so நம்ம elongate பண்ணா we are trying to move the mass to the right side. restoring force will be exactly opposite direction. so பாருங்க, the restoring force அதோட வேல்யூ என்னது, k into x தானா. if you are elongating by a value x means அந்த ஸ்ப்ரிங் குள்ள இருக்கிற restoring force will be what, k times of x. okay, இப்போ நம்ம என்ன பண்ணலாம், we will give a very small displacement dx. okay, ஏன் ஸ்மால் டிஸ்பிளேஸ்மெண்ட் அதே நான் சொல்றேன். Okay, so consider a very small displacement dx. A small displacement தெரியுமா? If you are taking a longer displacement of that mass, spring force oda value will changing. எதனால? Because if you give a large displacement வச்சுக்கோங்க, then the elongation oda value will be considerably changing. அதனால the spring force value will change. So what we are taking is a very small displacement dx. For the small displacement பாருங்க, the small displacement is towards, still நம்ம elongate பண்ண மாதிரி, we are giving it towards the right side. When you take it from point 1 ல இருந்து up to point 2, what is the work done by the spring force? இங்க என்ன தெரியுமா? The work done by the spring force also will be very small value. ஏன்னா displacement is small, right? So பாருங்க, what will be the work done? Spring force left side ல இருக்கு, displacement is to the right side. இப்போ என்ன வரும் பாருங்க, kx into dx into cos 180 வரும். A cos 180 because the angle between them எவ்வளோ? So we are displacing the mass to the right side, spring force is to the left side. Okay va, 180 degrees is the angle between them. 180 means cos 180 எவ்வளோ? -1 தானா? So what is it? minus kx dx ஆயிடும். அதோட வேல்யூ என்னது? minus kx dx. Okay, so this is what small work done when you take the mass from point 1 to point 2. இப்போ என்னன்னா, we'll try to make it like a closed loop. எப்படி நம்ம அந்த closed loop கன்வெர்ட் பண்ணலாம்? அப்படியே திருப்பி நம்ம 2 ல இருந்து 1 கிட்ட கொண்டு வரலாம். ஸோ 2 to 1, 2 to 1 நம்ம மூவ் பண்ணும்போது what is the thing? இங்க பாருங்க, டிஸ்பிளேஸ்மென்ட் வேல்யூ will be same, dx தான், இங்கேயும் dx தான் வரும், பட் டைரக்ஷன் எப்படி? லெஃப்ட் சைட். ஸோ அதனால the work done by the spring force இங்க என்ன தெரியுமா? it will be positive. Why? Because இங்க என்ன வரும்? cos 0 வரும். We are giving the 2 to 1 means we are giving the displacement to the left side. Spring force எப்படி இருக்கா? towards the left side. So the angle between them is what? 0. So அதனால we are getting it as what? cos 0. Okay, பாருங்க, what is it? இங்க என்ன வரும்? kx dx வரும். Okay, so this is the small work done when you bring it from 2 ல இருந்து 1. Total work in that closed loop. So இப்போ நம்ம எடுத்தது என்ன? closed loop, but very small closed loop. ஏன் நம்ம இந்த very small closed loop எடுத்திருக்கோம்? Because spring force is a variable force. நம்ம ஒரு பெரிய லூப் எடுத்தோம்னு வச்சுக்கோங்க, தென் ஸ்ப்ரிங் ஃபோர்ஸோட வேல்யூ சேஞ்ச் ஆகிட்டே இருக்கும். அந்த மாதிரி ஒரு சுச்சுவேஷன் நம்ம சால்வ் பண்ணோம்னா இட் வில் பி இன்வால்விங் அந்த இன்டிகிரேஷன் கான்செப்ட் அதெல்லாம் வரும். ஸோ இப்போ இந்த வெறும் இந்த அனாலிசிஸ்க்கு மட்டும் அந்த அளவுக்கு நம்ம போக தேவையில்லை. ஸோ வீல் ட்ரை டு அனலைஸ் பை யூசிங் எ வெரி ஸ்மால் க்ளோஸ் லூப். ஓகே, ஸோ பாருங்க, இந்த வெரி ஸ்மால் க்ளோஸ் லூப் நம்ம எடுத்ததில் வாட் இஸ் த டோட்டல் ஒர்க் டன் மீன்ஸ், இந்த ரெண்டு வேல்யூஸ் நம்ம அப்படியே ஆட் பண்ணோம். வாட் இஸ் இட்? minus kx dx plus kx dx. total value எவ்வளோ வருது? 0. so அதனால when you look at the closed loop of that mass நம்ம எடுத்த மாசம் we are moving it in a closed loop. அப்படி மூவ் பண்ணா what is the work done by the spring force? it will be what? 0. what is the work done by the spring force? it is coming as what? 0. so that is the reason why we can say என்ன சொல்லலாம்? spring force is also a conservative force. திருப்பி நான் சொல்றேன், இது என்ன தெரியுமா? this is நம்ம ஹெட்டிங்ல ப்ரூவ்னு போட்டிருக்கோம். ஓகே, பட் இங்க நம்ம பண்றது என்ன? we are trying to analyze. எப்படி? like we are not giving a general proof. இது general proof கிடையாது. we are taking a particular example. so we are giving a displacement of dx அந்த டைரக்ஷன்லயே, like kx is along a line வச்சுக்கோங்க, horizontal direction இருக்கு kx. we are moving the body in the same horizontal direction, small value dx திருப்பி பின்னாடி கொண்டு வர மாதிரி. like this is a particular case, it's not a general case. okay va? so what we are doing here is we are trying to analyze எப்படி how that spring force is behaving like a conservative force. okay, இதுக்கு அடுத்த ஸ்டேஜ்ல என்னன்னா we can look at how the gravitational force, which is the general form. இப்போ நம்ம எடுத்தது என்ன? the simplified formula for the gravitational force acting on a mass which is close to the surface of the earth, which is our mg. okay, but generally நம்ம gravitational force expression பார்த்தா what is it going to be? Newton's law of gravitation. அது என்னது? if we are having two masses m1 and m2, the gravitational force of attraction between them will be what? capital G into m1 m2 by r square. அதுதானா? so what is the universal Newton's law formula? what is it? If you are having two masses, m1 and m2 separated by distance r, the gravitational force of attraction them will be what? G, capital G into m1 m2 by r square. This capital G and it is the universal gravitation constant. Okay, m1 m2 are the respective masses and r is the distance between them. Okay, so we will consider that the masses are actually point mass. Already நம்ம பேசிருக்கோம் point mass என்னன்னு சொல்லிட்டு. Point mass is what? So usually in mechanics என்ன தெரியுமா, we will say that no distance between two objects ன்னு சொல்லிட்டு. அந்த மாதிரி ஒரு இதுல we are assuming that the object is actually located at a single point. Okay, அது ஒரு assumption தான். ஏன்னா no object will be located at a single point because object is going to occupy volume. But mechanics la நம்ம இந்த analysis la என்ன தெரியுமா, we will try to take the objects to be what? Point masses. Point masses சொன்னா what is it? We will consider that the object is located at a single point. Okay, அது ஒரு என்ன சொல்றது, ஒரு simplified way of studying the mechanics part. Okay, so we will try to see later when we go to gravitation chapter, right? அங்க என்னன்னா we will try to see how that general gravitational force formula based பண்ணி how we can see that the gravitational force is a conservative force. அதே நம்ம பார்க்க போறோம் when we go to electrostatics. அந்த மாதிரி when we go to magnetism, right? We will try to see how those forces are also becoming conservative forces. Okay, so இங்க என்னன்னா there is a reason why it's not like generally நம்ம ஏதோ ஒரு classify பண்ணணும்னு சொல்லிட்டு ஒரு புது classification கொண்டு வரது கிடையாது. So there is a reason why we are classifying the forces into conservative and non-conservative. Okay, so that we will try to understand later. But இப்போ என்ன தெரியுமா, we will look at another important property of the conservative force. ஒரு property என்ன, the work done by the conservative force in a closed loop will be zero. This is one property, right? இப்போ நம்ம பார்க்க போறது second property. Actually என்ன தெரியுமா, the second property will be proved by using the first property only. Second property இங்க பாருங்க, what is it? The work done by the conservative force will be independent of the path followed between any two points. And this is the second property. If you have a conservative force னு வெச்சுக்கோங்க, ஆல்ரெடி நம்ம ஒரு ப்ராப்பர்ட்டி பத்தி பேசியிருக்கோம். What is it? In a closed loop work done by the conservative force எவ்வளவு? zero. இங்க பாருங்க, what is the second property? If you are taking the object or any mass from 1 to 2, பாருங்க நிறைய பாத்துல நம்ம எடுத்துட்டு போலாம். Let's say this is ஒரு path A ன்னு வெச்சுக்கோங்க. Okay, we can have different paths இருக்கலாம். Okay, so we can have another path. பாருங்க, so this can be another path. இது என்னது, path B ன்னு சொல்லலாம். You can have one more path. I mean you can give like whatever number of paths you want, you can create, right? அப்படியே நம்ம நிறைய paths create பண்ணலாம். இது என்னது, path C. Like if you want to take a point from the initial location and is what initial location. So initial location la நம்ம final location கிட்ட எடுத்துட்டு போனோம்னா we can make this movement along different possible paths. But இங்க என்னது பாருங்க, work done is independent of the path followed between any two points. இப்போ நம்ம point 1 ல இருந்து we are going up to point 2 வெச்சுக்கோங்க. Then work done in the path A will be same as work done in the path B will be same as work done in the path C. இதுதான் second property of the conservative force. இப்போ நம்ம different இப்போ non conservative force என்ன ஆகும் தெரியுமா, these work values will not be equal. non conservative force என்ன ஆகும், the work is going to depend upon the path followed. Conservative force case மட்டும் தான் work will be what, independent of the path followed. ஓகேவா? So இது எப்படி நம்ம ப்ரூவ் பண்றது? So first we have understood what is the second property. Okay, so which is what, when you move a object from one location to the other location, work done by the conservative force will be independent of the path. The path மேல depend ஆகாது. Which means what, if you take in different paths means each and every path the work done will be same. Okay, இங்க பாருங்க, so we are trying to move the object, any object from point 1 to point 2. Okay, so இது என்னது, we can say onward. Okay, so we're taking it from point 1 to point 2. Either let us say that now the work is what, x. What is the work value? X. So the value நமக்கு தேவையில்லை. Let's say the work is what, x. இப்போ என்ன தெரியுமா, we want to make it a closed loop by bringing it back from 2 to 1. Okay, so இங்க பாருங்க, I can bring it from 2 to 1 in a path A. I can bring it from 2 to 1 in a path A. Or என்ன பண்ணலாம், we can bring it in different path. 2 ல இருந்து 1 கிட்ட we have to bring it, means we can bring it in a different path. Okay, you can bring it in another, you can have various paths, right? நிறைய விதமா நம்ம கொண்டு வரலாம். So look at this, I can bring it in path C. இப்போ என்ன தெரியுமா, the onward journey means what, we are going from 1 to 2 plus the path A. பாருங்க, what is it, இது என்னது, closed loop தானா? So we are going from 1 to 2, திருப்பி 2 ல இருந்து we are coming back to 1, which is the closed loop. So what is the work done in the onward? X. Work done in the path A, let us say it is what, W and which loop. So total value will be what, 0 dana, because what done in a closed loop is what, 0. So idhilende we are getting W is equal to what, minus X. அப்படியே இருக்கட்டும். We will go to next, the relation in terms of the path B. இங்க பாருங்க, onward means what, going from 1 ல இருந்து 2 plus path B, இதையும் ஒரு closed loop தான். இப்படி பாருங்க, so we are going from 1 to 2, திருப்பி we are coming back from 2 ல இருந்து up to 1, இது என்னது, closed loop தானா? So this onward plus path B is also what, இதையும் ஒரு closed loop தான், which means what, onward ல what is the work, X. Let us say work in the path B எவ்வளவு, WB னு வெச்சுக்கோங்க. Total value will be 0, right? Because that is a conservative force. So work done in a closed loop எவ்வளவு, 0. So அதுல இருந்து we are getting WB ஓட value, what is it, இதையும் minus X தான். Last case எடுக்கலாம், what is it, we'll try to include the this one, என்னது, path C. இங்க பாருங்க, onward plus path C. onward ன்னு சொன்னா what is it, 1 ல இருந்து 2 கிட்ட எடுத்துட்டு போற மாதிரி. திருப்பி நம்ம we are coming back from 2 to 1 in the path C. இது என்னது, this is also closed loop தானா? இது ஒரு closed loop தான். So closed loop means onward, what is the work, X. path C ல WC னு வெச்சுக்கோங்க. total work is 0. So இதுல இருந்து என்ன வருது, WC ஓட value is coming as what, minus X. பாருங்க, so which means what, the W ஓட value is same as WB is same as WC. So what is the conclusion, the work done by the conservative force, இது என்ன தெரியுமா, conservative force மட்டும், will be independent of the path followed between any 2 points. இப்போ நம்ம point 1 ல இருந்து point 2 கிட்ட மூவ் பண்ணா the work will be what, independent of the path followed. Okay va? So this is about the second property of the conservative forces. பாருங்க, to prove this right, நம்ம அந்த first property use பண்ணிருக்கோம். What is this, what is the first property, work done in a closed loop is 0. So அந்த proof ல, I mean, so whatever the result, right, and the result use பண்ணி தான் we have proved the second property. Okay va? So this is about the second property of the conservative force. Okay, இப்போ நம்ம conservative force பத்தி பேசிருக்கோம். What is the other type of force? So எந்த ஒரு force is not able to meet these properties, like you know, work done in a closed loop is not equal to 0, அந்த மாதிரி work done is depending upon the path. அப்படி இருந்தா then what do we call such forces as non-conservative force? எது conservative force இல்லையோ, that is going to definitely become what, non-conservative force தானா? So look at, you know, what can be some examples of the non-conservative force. So நம்ம கிட்ட இருக்கிற force ல தெரியுமா, we can consider this friction and see how it can become a non-conservative force. So we try to see how the friction becomes a non-conservative force. இதுக்கு என்னன்னா, we will try to start with a example that we already discussed. இதுக்கு முன்னாடி நம்ம எடுத்த example தான். இங்க பாருங்க, so we are trying to move an object of mass m along this rough surface. The rough surface மேல there is an object, okay, mass m. அதனே we are trying to move it from point 1 to point 2. So நம்ம அப்படி மூவ் பண்ணும்போது what is the frictional force என்ன relative motion இருக்குங்க. The frictional force என்னது? It is the kinetic friction, right? இங்க இருக்கிற friction force என்ன? Kinetic friction தானா? So kinetic friction எப்படி act ஆகும்? So நம்ம movement right sideல கொடுத்தா kinetic friction will be opposite direction. So the displacement S ன்னு வெச்சுக்கோங்க towards the right side. So work done by the kinetic friction in taking that mass from point 1 ல இருந்து up to point 2. இங்க பாருங்க displacement எப்படி இருக்கா? right side. Frictional force ஓட left side. So what is the angle between them? 180. So work will be what? Frictional force into displacement into என்ன வரும்? cos 180 வரும். What is it? Minus frictional force into displacement value. ஏன் minus வருது? Because cos 180 value என்னது? -1. Okay வா? So this is the work in taking it from 1 to 2. இப்போ என்ன? we'll try to make a closed loop. எப்படி பண்ணலாம்? how we can make it like a closed loop பாருங்க. திருப்பி நம்ம இந்த point 2 ல இருந்து we will bring this back. என்ன பாருங்க, we are trying to bring it back. so நம்ம தனியா நம்ம represent பண்ணலாம். பாருங்க இங்க we are trying to bring it back from 2 to 1. ஓகேவா? so இப்போ என்ன தெரியுமா? we are giving the displacement yes to the left side. 2 ல இருந்து we are coming to 1 means what? we are giving a displacement same value same da, but direction change ஆயிடும். direction is what? towards the left side. but இப்போ என்ன தெரியுமா? look at the frictional force. frictional force எப்படி act ஆகும்? because we are trying to move the, சரிங்க பாருங்க, we are trying to move the block to the right side வெச்சுக்கோங்க. then friction will be opposing it, means friction is going to act to the left. always friction is going to oppose the relative motion தானா? kinetic friction always opposes the relative motion. இங்க என்னது? we are trying to move the block to the left. இப்போ நம்ம left side move பண்றது ட்ரை பண்ணா what is the frictional force going to do? it is going to oppose it, means it will be acting exactly opposite direction act ஆகும், which means frictional force will be acting to the right side. இப்போ இங்க பாருங்க, work done in bringing from 2 to 1. force என்னது? frictional force value change ஆகாது, which is what? mu k times normal reaction. kinetic friction ஓட value என்ன? mu k into normal reaction, அதுதானா? into displacement value change ஆகல. yes. இங்க பாருங்க, what is the angle between the frictional force and the displacement? இங்க எவ்வளவு இருக்கு angle? displacement is toward the left side, frictional force is to the right side. angle எவ்வளவு? திருப்பி 180 தானா? so what we'll get? into cos 180 வரும். what is cos 180 value? -1. இப்போ பாருங்க, what is it? திருப்பி minus frictional force value into displacement. so closed loop நம்ம எடுத்திருக்கோம். what is it to 1 ல இருந்து we are going up to 2, திருப்பி 2 ல இருந்து we are coming back to 1. closed loop தானா? so இங்க பாருங்க, work done in this closed loop. இப்போ நம்ம எடுத்த closed loopல what is the work done? 1 to 2 plus 2 to 1, அதுதானா? so what is this? so add பண்ணா என்ன வருது? it is not becoming 0 ஆகலன்னா what is it? this is actually a non-conservative force. இதுல ஒரு இன்ட்ரெஸ்டிங் என்ன தெரியுமா? to prove something you have to prove, நான் சொன்ன மாதிரி general case or அப்படி நம்ம prove பண்ணதா you have to prove it for all the cases, then only we can say it is correct. but if you have to prove that the friction is not a conservative force, அதுக்கு நம்ம ஒரு எக்ஸாம்பிள் கொடுத்தா போதும். because so இப்போ sin square theta சொன்ன மாதிரி sin square theta plus cos square theta is equal to 1, அது நம்ம prove பண்ணோம்னா what is it? we have to prove it for all the cases. அது நம்ம என்ன சொல்லுவோம்? general method தான் நம்ம பண்ணோம். but if you want to say that that is the wrong, then if you give an example, one example கொடுத்தா போதும். இங்க எப்படிதா? like you are trying to say that friction is not a conservative force. அதுக்கு என்ன தெரியுமா? if you can give one example, that will be sufficient. இங்க பாருங்க, we are able to give one example, right? என்னது? we are able to show that நம்ம எடுத்த எக்ஸாம்பிள்ல friction is not satisfying that condition. என்னது? what in a closed loop is not equal to 0, which means what? this becomes a non-conservative force. ஓகேவா? so இப்படிதான் the basic difference என்ன தெரியுமா? for a conservative force, what in a closed loop will be 0. அதுல இருந்து we got second property also. என்னது? what done will be independent of the path taken between 2 points. அது ஒரு சைடுல conservative force. whichever force is not satisfying the properties, adanadi we will call them as non-conservative forces. Okay va, adukku oru familiar example enna, frictional force. Okay, so this is about the classification as conservative and then non-conservative forces. திருப்பி நம்ம இந்த கன்சர்வேட்டிவ் நான் கன்சர்வேட்டிவ் இப்போ என்ன தெரியுமா, we have just understood எப்படி இந்த கிளாசிஃபிகேஷன் வருதுன்னு சொல்லிட்டு. திருப்பி we are going to talk about the conservative forces, particularly we are going to talk about the conservative forces. Okay va, so we'll see what is the importance or what is the application of these conservative forces. But அந்த இதுக்கு போறதுக்கு முன்னாடி we will take a look at the main aspect of this particular chapter, enadhu the work energy theorem. What is the main aspect of this chapter? Work energy theorem. Okay, so na sonna madri, if the Newton's laws is based on that one formula, F is equal to ma, right? In the chapter enna theriyuma, this is going to be surrounding this particular concept. What is this concept? Work energy theorem. This is ரொம்ப important ஏன்னா because this is not only for this particular chapter, even நான் சொன்ன மாதிரி various other chapters also, right? We will have the work energy theorem and we will use conservation of momentum. Okay, இது ஒன்றும். செகண்ட் என்ன தெரியுமா, work energy theorem. So these two we will generally call as what? The four mechanics relations. Enadhi conservation of momentum. So what is conservation of momentum? Already நம்ம பார்த்திருக்கோம். What is it? So if there is no force, external force is not there, means the momentum of that object or the group of objects you take, the momentum will remain constant. So that is the conservation of momentum. Okay, so inga enna theriyuma, we are going to look at the work energy theorem. These two are actually called as the core mechanics equations on solala or the principles. They will be used not only inga mattum kadiyadu, they will be used in other chapters also, like when you are having the applications related to the movement or motion, right? Angyu we are going to talk about these two principles. Okay, so what do we call them as? Core mechanics principles. So whoever is good in terms of these two, right, whoever is comfortable in using these two relations, they will find the mechanics a little bit more easy. Okay, so pakala, what is this work energy theorem? First enna, we will try to understand what is the idea of this work energy theorem. First of all, the idea enna paranga. So idea enna theriyuma, very simple. So we will need to understand what is this energy. Okay, energy enna theriyuma, energy is a property of an object. Okay, by virtue of its state and solala, motion. Ena we are not having just one energy type, nariya irukka. Okay, so energy is a property of the object. So energy is associated with the object. Okay, so depending upon what? Depending upon the state of that object or motion, or we have a lot of other parameters also. Ena we are having different types of energy. Okay, so this is a property of the object. Basically work energy is a property of the object. Okay, so ipo enna parunga, if we are looking at any object, right, it will have some energy, and we can say it is what? Initial energy and so initial energy. Okay, when you are doing work, there will be interaction between the energy and the work that we are doing. So energy and so now what is it? Energy of that object. Okay va, so paranga, and during this process, right, is a process mother dana, what is happening? We are doing work on that object, means there is something happening, or phenomenon solala, or process solala. It could happen that energy of that object might change. It could happen that the energy of the object might be changing. Okay, அது எப்படின்னு சொல்லிட்டு we will try to analyze it later. Okay, but இங்க என்ன தெரியுமா, we are trying to just understand the concept of what is the work energy theorem. So work energy theorem oda basic idea enna theriyuma, it is nothing but the interaction, or neenga specific ah sollanona we can say it is a relationship. அது எப்படி வருதுன்னு சொல்லிட்டு நம்ம பார்க்க போறோம். But here basic idea என்னன்னு சொல்லிட்டு நம்ம பார்க்கலாம். What is it? It is the interaction or the relationship between the work done on an object and its energy. அவ்வளவுதான், சிம்பிள் கான்செப்ட். என்னது? இன்ட்ராக்ஷன். ஸோ இப்போ ஒரு ஆப்ஜெக்ட் மேலே நம்ம ஒர்க் பண்ண வச்சுக்கோங்க. தென் பிகாஸ் ஆஃப் தட் the energy of the object might be undergoing some change. அது எப்படி வருதுன்னு சொல்லிட்டு we'll look at it. But in the interaction between or relationship between the work done on the object and energy of the object, இந்த ஒரு கான்செப்ட் தான் ஒர்க் என்ஜின் தியரம். ஓகே, ஸோ இந்த ஐடியா மட்டும் நீங்கள் ஞாபகம் வச்சுக்கோங்க. we'll try to see what is the exact relation ன்னு சொல்லிட்டு we'll try to look at it later. But இங்க என்னன்னு just the basic concept. Okay, when we look at the energy, right? So energy, what are we saying? It's a property of an object by virtue of its state or motion. அந்த மாதிரி நிறைய சொல்லியிருக்கோம். Okay, so there are different types of energies. So what are the different types of energies that are there? So first and important thing என்ன தெரியுமா? Kinetic energy of the object. இது எப்படி வரும்? It is going to come by virtue of its motion. Okay, so kinetic energy is going to come by virtue of the motion. Second, we'll talk about potential energy. Potential energy என்ன தெரியுமா? It is the energy that is going to be depending upon the virtue of state and சொல்லலாம் or the configuration. It is the energy which is going to be depending upon the virtue. Virtue and சொன்னா on what parameter? So it is going to be depending upon the virtue of the state or configuration of the object. So இங்க ஒரு பாயிண்ட் சொல்லணும். என்ன தெரியுமா? Potential energy, it is not, so it's an important point. Potential energy is not possessed by the body. So potential energy ன்னு சொன்னா it is not the energy possessed by the body. ஓகேவா? So எப்படி, what is the difference between the potential energy and the other types of energies நம்ம இதை பார்க்க போறோம் when we discuss about the potential energy. But இங்க என்ன தெரியுமா? You will notice something interesting. பாருங்க, potential energy is defined for some specific forces. Potential energy is not the energy possessed by the body. It is the energy that is defined associated with some force. என்னது பாருங்க, what is the forces we are mentioning here? Gravitation, spring. What are these forces? Conservative forces. ஓகேவா? ஸோ இதை பற்றி நம்ம திருப்பி டிஸ்கஸ் பண்ண போகிறோம். ஸோ வாட் இஸ் த பொட்டன்ஷியல் எனர்ஜி? இட் இஸ் நாட் அ ரியல் எனர்ஜி அசோசியேட்டட் வித் தட் ஆப்ஜெக்ட். ஸோ கைனடிக் எனர்ஜின்னு சொன்னால் வாட் இஸ் இட்? த ஆப்ஜெக்ட் இஸ் மூவிங், ஸோ ஆப்ஜெக்ட் வில் ஹாவ் எனர்ஜி. பிகாஸ் ஆஃப் மோஷன் ஆப்ஜெக்ட் வில் பி ஹேவிங் சம் எனர்ஜி. பட் பொட்டன்ஷியல் எனர்ஜி அப்படி கிடையாது. பொட்டன்ஷியல் எனர்ஜி இஸ் கோயிங் டு கம் இன் a different way. அது எப்படின்னு சொல்லிட்டு நம்ம பார்க்க போகிறோம். ஸோ திஸ் இஸ் நாட் தி எனர்ஜி possessed by the body. It is energy associated because of the interaction of the body with the conservative force. Okay, அது எதுக்கு மேலே டிபெண்ட் ஆகும்? It depends on the state of that particular object or it depends upon the configuration. So நாம வச்சுக்கோங்க, what is it? Kinetic energy is a real energy. Kinetic energy is real energy that is there in the object. But potential energy அப்படி கிடையாது. Potential energy is what? It is the energy that is associated with the virtue of the state or the configuration. So it is the energy that is related to what? Interaction between the object and the conservative force. And the relation எப்படி வருதுன்னு சொல்லிட்டு we will look at it later. ஓகேவா? But this is the difference between the potential energy and kinetic energy. அடுத்தது என்ன தெரியுமா? Chemical energy. This is about the chemical composition. Maximum cases என்ன தெரியுமா? Our object is not going to change the chemical composition. Maximum case என்ன? Our object is not going to change the chemical composition. அதனால இந்த chemical energy ஓட டிஸ்கஷனே வராது. Chemical energy will depend upon what is the nature of molecules inside. ஒரு chemical reaction ஆகுதுன்னு வச்சுக்கோங்க, then the chemical energy will be changing. But if the chemical composition of the substance change ஆகலன்னா then no chemical energy ஓட டிஸ்கஷனே வராது. But this is about what? The chemical composition. But என்ன தெரியுமா? We have particularly ஒரு example, explosion example. Explosion சொன்னா what is it? Like a bomb or something exploding. Then in case of explosion என்ன தெரியுமா? We will see that the chemical energy of that object will be changing. And once the explosion is happening, right, there is a chemical change, right? So the energy coming from that explosion is going to result in the kinetic energy of the particles. Explosion ஆன உடனே what is going to happen? Mainly என்னாகும், all the things in surroundings, they will be thrown in different directions, right? So which means what? They are all getting kinetic energy. எங்கல இருந்து வருது? It is coming from the chemical energy form. Okay. Electrical energy ன்னு சொன்னா what is it? It is the energy associated because of the movement of the charges. Okay, wow. So this is particularly when the charges are moving, right? That energy associated with the movement of the charges, we will call them as what? Electrical energy. Then sound energy. Sound energy ன்னு சொன்னா what is it? It is about the disturbance in air or any medium that we give. Sound is what? It's a longitudinal wave. It's a disturbance, right? It's a form of energy only. Light energy and sonna, light or electromagnetic waves generally, they are what? They are the form in which energy will be transmitted from one place to other place, even in space. Like, energy from sun will come to the earth because of this electromagnetic waves. Okay, so what is this? This is a electromagnetic wave. So இதெல்லாம் நம்ம என்ன தெரியுமா, we'll try to study them in separate chapters. In fact, in the 12th syllabus என்ன தெரியுமா, we have a separate chapter itself. எப்படி, how the electromagnetic waves are going to propagate in space, how they will be associated with energy. அதெல்லாம் நம்ம இங்க we'll try to study this in the electromagnetic wave chapter. அந்த மாதிரி we can also talk about this heat energy. Heat energy என்ன தெரியுமா, it is also known as what? Thermal energy. Heat energy ன்னு சொல்றதுக்கு பதிலா what you can say thermal energy ன்னு சொல்லலாம். Thermal energy is what? It is the energy associated with the, இப்போ நீங்க ஒரு சிஸ்டம் ஆர் ஆப்ஜெக்ட் எடுத்தா வெச்சுக்கோங்க. If you consider a system or object, அதுக்குள்ள என்ன இருக்கும்? அதுக்குள்ள நிறைய பார்ட்டிகல்ஸ் இருக்கும். So you take a gas in a cylinder வெச்சுக்கோங்க, or anything will have millions and millions of molecules ஆகலாம் or the atoms. ஓகேவா? Depending upon the temperature value, these particles will not be at rest. They will have what? The thermal vibrations irukala, or they can have a translation motion, or they can have a rotational motion. எந்த மாதிரி ஒரு இது இருக்கலாம்? They can have translation motion, they can have rotational motion, they can have vibrational motion. If you add up all these energies of the small particles, இங்க என்ன தெரியுமா, நீங்க கரெக்ட்டா ஞாபகம் வெச்சுக்கணும். What is it? If the container of the gas is at rest, and the container full of kinetic energy கிடையாது, because the container is at rest. But container குள்ள இருக்கிற gas particles, right, they are in constant vibration, they are in constant translation motion. ஏன்னா we'll study about this in the kinetic theory of gases chapter. So how the gas particles are going to move and how they are going to behave. So they will be having what? Translation motion இருக்கும், they will be having vibrational motion, they will be having rotational motion. So if you look at all these energies of the particles of the particular substance, அதெல்லாம் நம்ம add பண்ணா what you are going to get? The total heat energy of that particular system ன்னு சொல்லலாம். What is it? Total heat energy. Okay va? So this is also we call as what? The micro level energies. Another micro level energy ன்னு சொன்னா what is it? It is the energy associated with the small particles of that particular system. Okay va? அடுத்து என்ன பாருங்க, nuclear energy. இது எங்க வரும்? So nuclear energy ன்னு சொன்னா it is the energy associated with the nucleus. So when we will be able to realize the nuclear energy, when you have a nuclear reaction and solala or nuclear phenomena. So if you have two lighter nuclei combining to give you a larger stable nuclei, adukana we will call it as what? Fusion and solo. Fuse panna madri, two smaller nuclei combining to give a larger nuclei. So usually the hydrogen bomb works on the principle. Stars and they all release energy because of the fusion. Okay va? We have one more phenomena called as nuclear fission. Break panna madri, fission. Okay, So a large unstable nucleus like uranium or plutonium, they undergo the fission breakdown and they will give you energy. So what is that process called as what? Fission. So most of these nuclear power plants, right, they are based on the nuclear fission concept. Most kadayadu, all the power plants are based on the nuclear fission. And a fusion is in terms of the energy wise, right, fusion will be able to give us much more energy, because understandable, right? For the sun and the stars, what is the source of the energy? It is the nuclear fusion. Other than that, they are getting so much of energy. But the fusion process, right, will be extremely violent. So நம்ம அதை பத்தி படிக்க போறோம். So in the modern physics chapters, it will be extremely violent and uncontrollable fusion. Okay, so if you want to take out the energy, say for example you want to drop a nuclear bomb in a particular, like that should never happen, but yeah, so if you are creating something for destruction, there is no need to control it. So we don't need to control it. That's the reason why we also have something called as a hydrogen bomb. Normal nuclear bomb is what? Nuclear bomb is based on the fission concept. Hydrogen bomb is based on the fusion, the phenomenon that happens in the sun and stars. Okay, va? So for the destruction purpose, you don't need to control it. So adanal they are able to design these hydrogen bombs also. But if you want to extract the energy for a useful purpose, right, you need to control it. Control panna mudiyalana, everything will be explosion dana. So fission, the process of breaking down of a larger nuclei like uranium or plutonium, right, that can be controlled. Adapatti we will discuss about it in detail, but that can be controlled. So people are able to design nuclear reactors with lot of precautions. Nariya precautions eduthittu they are able to design the nuclear reactors where energy from the nuclear fission can be taken out and used for producing current electricity. Adu mattum kadiyadu, even some of the spacecrafts also, right, they are using this nuclear energy for not for propulsion but for the energy requirements inside the spacecraft kulla will require they require current, right? How they produce, they'll produce based on the small nuclear reactors that they keep inside. And there is a lot of research and advance that is going on, because nuclear energy, right, is a very abundant source of energy. But whatever we should have the safety precautions. We usually talk about it, right? What are the disasters caused by the dropping of the nuclear bombs on Hiroshima, Nagasaki, or the disaster of this Chernobyl in erstwhile USSR. What is the disaster caused by the nuclear explosion in Chernobyl? Even today, when you actually go there to the Chernobyl location, right, people can still feel the radiation. And in Hiroshima and Nagasaki, even generations and generations after, people are born with defects, and we will get genetical disorders. The nuclear radiation, right, will create what? Genetical disorders. Like people will be born with 1 ear. People will be born with probably just one side developed, one side develop agame, like so only one side, one eye, one part of the nose will be open, one side develop agadu apdi, like it will be very distressful to think about what will be the kind of effects the nuclear explosion or the nuclear radiation can have on the human beings. So skin cancer and all these things are very much common things that you'll see. Okay, but more than that, what it causes is it will change the biology language, right, change the DNA of the person, where the offsprings, right, further generations, they will be born with defects. Okay, so this is about the different types of energies that we have. But idhila namakku enna venum parunga, when we're discussing about the mechanics, right, when you talk about the explosion case, and our case mattum we will be looking at the chemical energy part. But electrical energy enga varudhu, it will come in the current electricity chapter, electrostatics adula varum. Sound energy will come in waves. Light energy we'll discuss in electromagnetic waves and the madri optics adula varum. Heat energy we'll discuss in thermodynamics. Nuclear energy we'll discuss in the modern physics chapter. But inga enna theriyuma, our focus is mainly on what the kinetic energy and potential energy. In terms of the mechanics, means what you have an object, adoda chemical composition அப்படியே இருக்கா, okay, அதுக்கு மேல there is no radiation phenomena happening, and that object is not related to the flow of charges, or it is not related to producing of the sound, idella involve agala. So we are looking at only what the kinetic energy, it is the energy associated with the motion, and இன்னொரு form of energy enna potential energy. But நான் already difference பத்தி பேசியிருக்கேன். What is it? Potential energy is not the energy associated with the body. It is the energy due to the interaction between the object and the conservative force. அது எப்படி வருதுன்னு சொல்லிட்டு we look at it. Okay வா? So first we'll start our discussion with what? Kinetic energy. So we can say it is what? The real energy possessed by the moving body. So என்னது பாருங்க, what is the kinetic energy? It is the energy possessed by a moving body by virtue of its motion. That is what we call as what? Kinetic energy. So which means if there is a motion, then there will be kinetic energy. If there is no motion, then there will be no kinetic energy. So what is kinetic energy? It is the energy associated with the virtue of motion. If there is a motion means kinetic energy irukum. If there is no motion for the object means there will be no kinetic energy. That's simple. Okay, so the energy associated with the movement or motion of the object is going to be called as what? We will call it as kinetic energy. Okay va? So look at it, what are the different types we can see around us in terms of kinetic energy. Paranga, if you have water flowing, so the water flow rate will have kinetic energy, and because water flow means what? All this mass of water. So if you look at the mass of water, that will be flowing, right? It has got kinetic energy. So this kinetic energy we will use it. The flow of water has got kinetic energy and solitary. We will use it to run water mills. Water mills and so you have a specific setup. Okay, so this energy from the flowing water, right, can be used to perform some mechanical work. It can be used to perform some mechanical work. Okay, so those are generally called as what? Water mills. Like the way we have windmills. Windmills, what is it? You'll have a turbine which is generally kept at a very large height. Okay, the moving air, moving air will also have the kinetic energy. So that energy is எப்படி நமக்கு தெரியும்? அது kinetic energy இருக்குன்னு சொல்லிட்டு எப்படி நமக்கு தெரியும்? We will know that there is a kinetic energy because this can rotate a turbine. So on the top of that wind tower, right, you'll have a turbine, right? So it will rotate the turbine. So if you go to Coimbatore, Pollachi on the side, you will see that lot of places have got, even Tirupati, you will see that there will be a lot of these wind turbines. Okay, they will try to produce what? Electrical energy. They will try to produce what? Current. So they are called as what? The wind power stations. So that is a non-conventional source of current. Okay wow? So conventional is what? Because of this the thermal power plants is what? Conventional source. Wind, all these are what? Solar, all these are what? Non-conventional. Okay, so generally government is trying to promote the non-conventional. A moving vehicle, so if you have a moving vehicle, right, if the moving vehicle is coming and hitting something, we will be able to feel the impact. Okay, so we will be able to feel the impact. So we'll say what? This is moving object is having some energy. So what is that energy? It is the kinetic energy. Okay, when you have a hammer, இது பத்தி ஆல்ரெடி நம்ம டிஸ்கஸ் பண்ணிருக்கோம் in the laws of motion chapter. When you are trying to hammer a nail into the wall or a wood, right, so we'll ensure that the contact time between the hammer and the nail is very small. We'll just try to hit it and we'll take it back. The contact time we'll try to have very, very small. So the hammer which you are moving fast, when we hit it, right, the kinetic energy of the hammer is transferred to the nail. Adanal nail is going in. So how the nail is able to penetrate inside, because when we hit the nail with the hammer, the kinetic energy of the hammer is transferred to the nail. Okay va? And the bullet fired from the gun. So bullet fired from the gun, it will be able to penetrate into the target. Okay, it can be a human or anything that is there in its path, it will be able to penetrate. Okay, so it is able to penetrate because of the kinetic energy. The bullet that is fired will also have what? Kinetic energy. Namagarka, we talked about, with regard to the bullet, we talked about what? The recoil speed or recoil velocity. When the bullet fire panna, the person who is firing the bullet or the gun will get what? The recoil velocity or the recoil speed. Okay, so bullet, when you fire it from the gun, it will have kinetic energy. Because of this, it will be able to penetrate to the target. Okay, wow. So all these are what? Some of the common examples of the kinetic energy. Okay, if I don't know, we'll try to look at how do you measure this kinetic energy? A moving body is having kinetic energy in solid go. That is fine. So how do you measure this kinetic energy? Eppadi the kinetic energy measure pandrathu? Adukana theriyuma, we have two methods. We are having two methods to get the expression for the kinetic energy. First method is using the equations of motion. Equations of motion enna theriyuma? The equations of motion we have seen in the kinematics. Okay, adu base panni we can derive the expression for the kinetic energy. We also have one more method, that is the integral method. So we have the applications of that integral method. Adu base panni we can find out what is the kinetic energy. Okay, so our next task is what? To find the expression for the kinetic energy. A moving body is having kinetic energy, we are able to come to the conclusion. But the value, what is the value of that kinetic energy? On what things the kinetic energy will depend upon? So moving body is having kinetic energy, and so we will be able to think about one thing. What is it? That kinetic energy will depend upon the speed or the velocity of the object in solitude. We will come to some conclusion. But what is the exact relation? Is it proportional to V, or is it proportional to V square, or is it proportional to V cube? What is the relation between them? We will try to start with this discussion in the next class. So now we will start with what? The derivation for the kinetic energy of the object. Okay, adukapram we will look at some applications of the work energy theorem. Okay va? So in the kinetic energy concept mudichittu, we will talk about the work energy theorem and some applications of the work energy theorem in the next session. Okay, we will see in the next session.